We are not content with just trying to gaze out into the cosmos and find evidence of that alien life. We want to contact them. We want to be in communication with them. So, here are some examples of things that we're doing to reach out there. On some of our spacecrafts, say on like Voyager, we've included etchings like this. You may have seen these pictures before, but let's go into detail what they are a little bit. Here we're showing a picture of the hydrogen atom and what we call the hyperfine transition. Physics is same everywhere. It's one of our foundational principles about this universe, that no matter where you live, we're going to agree on the laws of the universe. And so by putting this hyperfine transition on this picture of the simplest atom, what we're saying to whoever finds this is that A, we know about quantum mechanics, and B, we've picked the easiest thing to communicate that, because we'll all agree that the proton must have this kind of transition to it. On top of that, we've given them a map to us. We said, hey, if you look into the Milky Way and trace out a line from the galactic center and find these 14 pulsars. Pulsars are a great way to track positions inside a galaxy. So find these 14 pulsars, trace their intersection, and you'll find Sol. And on Sol is where you're going to find these planets along with us on it. The image of Earth being the origin of the spacecraft. Right? Notice the shape of the diagram. Right? The diagram is supposed to represent the shape of the spacecraft itself. And the spacecraft is drawn to scale with human beings present on this. So this is our way of saying, hey, you have found our spacecraft. You've found this to scale. Here's us. Here's what we look like. We're trying to communicate to whoever is out there how to find us, how intelligent we are, and what we are. On top of that, on Voyagers, we've given this golden record that has some of the same information imprinted on it. And in it, basically a phonograph, the ability to play music. And we're hoping that this image here is enough to tell whoever finds this how to access the information. So recorded on this is music, greetings in 55 different languages, and different images. We want whoever finds this to know about us. And we want to make a plea to them, a welcoming almost. So it's so important that I think it is worth reading. This is a message on the Voyager record. This is a present from a small, distant world. A token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours. We hope someday, having solved the problems we face, to join a community of galactic civilizations. We record this record represents our hope and our determination and our goodwill in a vast and awesome universe. We can't just throw probes out in the cosmos and hope some alien species finds it. We're also going to broadcast ourselves. This image here is a representation of the information the Arecibo radio telescope beamed out towards star cluster N13. So inside that radio message was information like the numbers 1 through 10, depictions of hydrogen and carbon atoms, a brief description of the bipedal organisms that created that signal, and more. But think about this. Radio was only invented in 1890. So if we assume that the first radios were power enough to reach out in the cosmos, then we've only been broadcasting ourselves to the universe for a century. Put that in perspective. Only aliens living within 100 light years could have possibly picked up any signals that we have sent out there. Only 100 light years. The Milky Way is thousands of light years long. But I do always love to picture the idea of some alien race sitting out there and watching shows like I Love Lucy. It's not impossible. Not probable. but I like to think this is happening. We're not only broadcasting ourselves out there, we're trying to detect any alien signals coming towards us. One of those examples would be the SETI radio telescopes, or the Search for Extraterrestrial Intelligence. And these would be radio telescopes that are scanning the skies, trying to find radio signals that have information in them of communications, prime numbers, information that could indicate that it's some sort of not random event, but a civilization trying to communicate out there. Another one is the Allen Telescope Array. This is a combination of about 40 radio telescopes, all working in unison, and they're trying to survey millions of stars over several years. Just trying to process quickly as possible, scan as many stars, and see which one of those might have alien life broadcasting from them. So in our hunt for other civilizations out there, one topic that's come out is what we call the Fermi Paradox. And this was based off of a series of discussions between physicists like Enrico Fermi. And here's what it boils down to. The argument is that there should be aliens out there. Just in the Milky Way alone, there are billions of stars. Many of those stars are going to have Earth-like planets. And the argument goes is that, hey, the Milky Way could be traversed in a few million years. All you need is this craft that's just using solar radiation, and it technically could take only a few million years to traverse the entire Milky Way. So if it only takes a few million years to travel across the Milky Way, and Earth is 4 billion years, where are the aliens? All right? We should have been visited by aliens, or at the very least, their technology by now. Now, some arguments for why we haven't seen alien life. One of the arguments is just, hey, life's extremely rare. These are really optimistic estimates. Another possibility, there are no other intelligent species. Or if there are, there's just not many of them. One possibility, and this is now pure speculation. We're starting to shift outside the realms of science and more into philosophical discussions. One of them is called the Great Filter. And it's a sad, pessimistic view, but the argument is that, hey, intelligence, life, natural tendency is to destroy itself. Maybe a less pessimistic idea is that there are periodic extinction events. We know of several extinction events on planet Earth alone. So if it takes millions of years to traverse the Milky Way, it's possible that a previous species of Earth was visited by aliens, but they've since died out. So related to that, humans, we just haven't lived long enough to find those aliens out there. Related to this concept of the Fermi Paradox is something called the Drake equation. Basically, what this is trying to estimate is, hey, what is the number of civilizations in the galaxy? Civilizations that are intelligent enough, that could technological capabilities to either communicate or optimistically traverse the stars. So, one thing I want to emphasize here is that this is an estimate. The idea is, well, how many civilizations are out there? Well, you're going to have to know the average rate that stars are forming. We know this number pretty well. Any number that's bolded is something that we have a fair estimate of. We know the rate that stars are forming in the Milky Way. And we have a fairly decent idea of what fraction of those stars are going to have planets. And we can reasonably calculate the number of those planets in habitable zones around those stars. So that gives you the first three terms. Everything after that is purely speculation. After that, we're trying to say, hey, of the planets in the habitable zone, what fraction of those will develop life? Of the fraction that develop life, how many of those will develop intelligent life? Not just microbial organisms, but things of intelligence, things that are probing physics, building probes. And that gets us to the fraction that create technology. Can't just be smart enough to spear your food and hunt. You need to create technology to expand your horizons. And this last one is how long you've been around. How long you've been present to send signals out into space. So these 4 here are guesstimates. You just can't know these numbers. We know these 3. So to summarize this, the Drake equation, it does not calculate the number of alien civilizations. I know that's what the equation says, but what this really is an estimating tool. The Drake equation is not this scientific principle. It's not going to tell us how many alien lives are out there. It's just a tool to motivate discussion, make us think about this. This diagram here is trying to represent this, right? The dots represent stars. And if we turn it to red, we means that we've eliminated it and there can be no intelligent life on those. So the more white dots we see, the higher the probability of intelligent civilizations existing there. So we'll go through this chain using optimistic assumptions for the Drake equation versus pessimistic assumptions. So optimistically, we could say these stars all have planets, or maybe half the stars have planets. We'll now eliminate the planets that are hostile to life, the ones where life's just not going to be stable. Right? Keep going down the chain. In a life that doesn't develop intelligence, eliminate a life that doesn't develop technology, and eliminate civilizations that just are not alive today. So we're just trying to come up with estimates, barriers of what number of civilizations are out there. If we're pessimistic, then we'd conclude that there may be only 1 or 2 civilizations in the Milky Way. If we're optimistic, there could be potentially hundreds, if not thousands, of civilizations. So once again, the Drake equation is just a tool to help us think, try and gather our thoughts, and make us comprehend, hey, what are the barriers to intelligent life, and what are the barriers to communicating technologically? One last thought about whether aliens could have possibly visited us is called the Penshermia Hypothesis. And this idea, life could have traveled the cosmos. Life could have figured out, pulled itself together, and traversed the giant cosmic distances, riding along on space dust, asteroids, comets, or even other planetoids, and have just seeded life across even potentially the galaxies. So it may be that alien life has visited us, or in a sense, our ancestors were the alien life that seeded on this planet and produced us. So we'll end this by looking at this image here depicting the Kepler Space Telescope, one of our best tools in finding exoplanets, planets outside of our solar system. So I'll remind you that life on Earth is all carbon-based, and we use DNA as a building block. We read the DNA, the genetic structure, to produce the proteins that function in us, producing all the biological reactions to make us nice, functioning, big organisms. We'll probably detect alien life by measuring planets' biospheres. Measuring what's happening in the atmosphere of a planet will be a predictor if there's life on this planet. And while we have yet to find alien life, the search will continue. So with that, we call it in to section 23 and an end to the course. So I hope you've all enjoyed this material. I strongly encourage all of you to continue exploring, continue looking up to the stars, looking up to the skies, and just ponder, just think. Never stop asking questions. Never stop trying to learn more. So with that, I wish you all farewell and take care.